Okay, folks, I'm gonna try to show you how to properly use Google Sheets and to help you do your lab report too, as we'll need Google Sheets for some of the future labs as well. The first thing we should do is pull up Google Sheets. This is simple. Now, this will allow us to do all sorts of math using either equal sign, plus sign, minus sign, the plus sign, no, plus sign, minus sign, multiplication sign, division sign, or even the power sign. And we can also do square roots as well, but I'll show you how to do that later. But all this, we can write whatever we want and use this just like a calculator. All you have to do is say, write an equals, and then whatever math you want to do. So 4 plus 9, hit enter, it solves it. What is 32 squared? So caret 2. If I don't put an equal sign, it's just going to leave it as that. But if I put an equal sign, it becomes a function that it will solve. 32 squared is 1024. Now, one of the neat things is that not only will it do whatever math that is in the box, we can also reference a particular box similar to as a location, similar to our the old game Battleship, that we would say, oh, A5, and would know to use whatever values are in A5. And we can copy things down and do a lot of math very easily. So I'm going to start by writing some little scripts. So let's fill up my reaction volume before I go any further. So I'm going to have A2S2O3, just for a reminder. What was its initial concentration? 0.001. Then I had Ki. Initial concentration was 0.01. Please leave out the units because it will get confused if you put in units. We can go ahead and put in the water, but we don't really need to. We're going to leave that out. So we're going to do KBRO3. Its initial concentration was 0.04, and our acid 0.1 HCl. So let's start by doing some quick math. So our math was, in each reaction, I took this concentration times 10 divided by 50. Now, it's suggested to autofill, but it would come up with a problem because you see that little dot in the corner? If I drag that down, it's going to change. Let's look at that. It changes my value of B1 to B2, which is, say, words times math equals confusing. So instead, we're going to change our little error. Now, to fix this, we're going to use what's called the always sign in an equation. Right now it says equals box B1 times 10 divided by 50. Well, if I use the money sign, it will say always B. Or if I use the money sign, it'll always 1. So right now I'm saying always, sometimes B, always 1 equals 10 divided by 50. Now, as I drag that down, notice it goes to B1, B1, B1. Otherwise, it would have changed. Now, if I can then drag that across, and because it's not always B, always 1, it move right, it changes to C, always 1. D, always 1. E, always 1. I'm looking right up here in this function box. And of course, I can drag these down. highlight all these and drag them down. Now, 2 of these will be wrong because, well, 3 of these will be wrong because this should be 20. And this should be 20. And this should be 20. So I now have my concentrations. So when you see the money sign, think cash money. This is where the box is at. This is the numbers I want to keep. So here's our concentrations. So let's put in our times. Let's say 1. So mixture 1. Well, let's say we did 2 times. 1A, 1B. And then average the time and say, okay. And then 1, average, 2, 3, 4. Okay, let's have our money. Say I'm going to make some numbers up. 120, 130. And then we're going to say, oh, that took about 55, and that took about 49, and that took about 34. So how do I do the average? Well, equals. To do an average, I can just type say equals and say average. And notice it will try to predict what you want. And say, here's some example equations. So average, and I'm going to highlight the boxes B8 and B9. Close with parentheses and hit enter. Okay, the average of that is 125. So let's put that 125. So with that, I have my basic times. So all that is the boxes we're filling in the first page. Then it asks you, over how many moles of S2O3 are needed to react with BrO3? Well, for every 6 moles of this guy, we had 1 mole of this guy. So our relationship was A was 1 and B was 6. Now, moving down, on the next page, it wanted the S2O3 divided by time, and they wanted the BrO3 divided by time. Now, the question was, why didn't they just go straight to the BrO3? Well, the reason why is because the BrO3 hasn't completed reacting. We cannot easily measure when the BrO3 has completed reacting because once it starts turning blue long before the bromate is completely consumed. However, it will not turn blue until this sodium thiosulfate has been completely consumed. So by measuring this, the thiosulfate consumption, we can measure this by relative rates. So, with that in mind, I can set equals. I can either type in the number or I can reference the box. I'll go ahead and reference the box. Actually, I'll reference this box instead, B1. I say I can either type it in or select the box B1 and divide it by my time. Now, as I scroll down, which one? I gotta make sure, yeah. Scroll down. What's going on? B2 divided by 13. What's the wrong with the? Oh, why did it go? No, it's not B1. It's B3. I want B3. There we go. B3 divided by time. And I have this. Now, this is really hard to read. So I'm going to actually change how this appears. I'm going to go up to here where it says more formats. I'm going to change this to scientific. That will make my life a lot easier when I go to read these guys. Now, with that in mind, how do I turn? So what I did is I selected the box. I could have just typed in the number, and I divided by my time box. How can I turn this into this? Well, here's where our ratio 1:6 comes in. For every 6 thiosulfates that gets consumed, 1 bromate gets consumed. So thiosulfate would be reacting 6 times as fast. So I'm going to take equals my B21 box, which was my first thiosulfate number, and divide this by 6. Or I could multiply this by 1/6. Either one works. And then it will even suggest autofilling this. So, and I can drag that out. So right now, oh, congratulations, I have my rates. The beauty of this is now I can recopy this data. Copy. Now, because of how I've typed this in, I want to paste special. I want only the values. I do not want the formulas, because the formulas will change with where its location is. So if I just do the values, that will keep the numbers. I'm going to go ahead and delete this box. I no longer need that. I just want to delete the cells and shift everything right, left. And I'm going to copy that values down as the rate. Copy, and once again, paste special. I want to paste the values only. So now I have my next box. So when I'm going to look at the order, I'm going to look at the comparison of 2 reactions where only one thing changes. So 1 and 2 is when iodide changes. 1 and 3 is when only bromate changes. 1 and 4 is when only acid changes. So the 2 rates. So I'm going to say rate 2/1. Rate 3/1. Rate 4/1. So I'll just say equals that box divided by that box. Equals that box divided by that box. And then equals that box divided by that box. Okay, with that in mind, so we're looking at the relative rates. Now, it's not a perfect situation, but one way to improve this is to say log 10 of this divided by log 10 of 2, which is your concentration change. And so if I do that for these numbers, it'll get the closest value. So clearly these 2 would round down to 1, and this would round up to second order. So my rate law now looks like this. My rate law is now rate equals K times, in brackets, I to the first, in brackets, BrO3 to the first, and H squared. Left out the charges. But so now they want us to find what is the relative Ks of our 4 trials. To do this, we have to rearrange this equation. So we can say rate divided by I divided by bromate. Well, actually, I'll just do it like this. Rate divided by these I times bromate times H squared. So that is what we're going to do, and that's going to equal our K. So to find our k values, do that. So equals this divided by, in parentheses, this times this power squared, in parentheses. I do that. Congratulations, we now have a k value. I scroll that down. I found 4 k values in an instant. Let's go ahead and turn this back into numerical rather than scientific. Now, if I want to do the average k, all I have to do is click average, and then select what I want to average. Boom, I have an average k value. Okay, that is the bulk of the math for part 1. Part 2, part B, is now we've changed the temperatures. We redid trial 1, now we changed the temperatures. So let's look at that. So hypothetically, we have temp in Celsius, temp in Kelvin, time, BR03, actually it's S2O3, BR03, time. I'm just recopying this. Team. We have our K, our ln K, and our 1 over T. So I have some numbers already worked out. 10, 21, 10C, our room temperature, about 30, about 40. And we can do with whatever values we have. Whatever values we have. So if it took 120, sorry, my bad. It took 381 seconds. I'm going to make up my, let's see, how long I said it took on average, 125. 72, and we'll say 24. Okay, this is all the information we need to do this math. Step 1, with this in mind, how do I get Kelvin? I can just take that number and add 273. If I drag that across, I have all my kelvins. How do I get the rate? Well, this was, remember, our initial concentration of this, which was 000. Let's see, what was it? Scroll all the way back up. 3 zeros and a 2. 0.00, 3 zeros and a 2. I'm going to divide that by my time. 3 zeros and a 2. I'm going to go ahead and turn that into scientific again, because that's going to make my life a little bit easier. I'm going to grab and drag that over because it's the same number. It's just divided by a new time, divided by C44, divided by D44, divided by E44, which is, your number may be different depending on how many spaces you've left, but I'm referring to the box, which I'm calling the time. How do I get this? Well, we did that before. It's this divided by 6. Drag that across. Okay? That 2.67, oh, that's still there. It's still the same. We're just doing it again. How do I do our K? Our K was our rate divided by the 0.002. Oh, wait, 0. Oh, yeah, 002. Let's look at my concentrations for my first plot. 002, 008, and 002. Okay. So times 0.008 times 0.02 squared. So I'm typing this mathematically in. And there's my k. This k, I'm going to go ahead and this k should match up with that k, and it does. Okay. So we have different k's. Okay, so to get the natural log, I'm going to type in the calculator, there's an ln button. In this math, there's a equals just ln, and I'm going to grab those numbers and drag that across. And so, okay, we've done that, doing that, boom. Okay, we got our k's. To do 1 divided by T, we're going to say equals 1 divided by our temperature in Kelvin. And that's a really small number, and that's fine. So, X and our Y-axis, I'm going to just go ahead and type those in. So we have 2.615, 3.729, we'll say 30, 4.28, and 5.38. So those are my 4 values. I'm going to put in our T 0.003534, 0.003414, 0.00331113, and 0.00319, I'll say 5. It doesn't really matter. I could grab the boxes, but I'm going to now graph this. So I'm highlighting these boxes. I'm going to insert a graph, so a chart. Highlight those, insert a chart. You want the, okay, I've done that wrong. So let's delete this chart and do this again. So I want, here, I'm going to go ahead and grab these and drag them. Okay, I'm going to cut and paste, and then I'm going to move everything down. Cut and paste. So the ln k is on our y-axis. The 1 over t is on our x-axis. We got to make sure we got that right. So I'm going to a chart. So here we go. Now, as I grab this, it should be an XY scatter. I want to make sure labels. Let's see. This is good. This is good. So we want to customize this data series. Let's see. We scroll down to the customization on the data series. We want to add a trend line. It should read linear. That is good. That's what we want. When it comes to a label, we're going to click down label, use equation, and ideally we want an r squared value. So my equation reads, so my m and my b. My m is negative 8013. My b is 30.9. R squared tells me how linear the values are. The closer it is to 1, the better your data fits the trend line. Now, due to the nature of this graph, that m is equal to negative activation energy over r, and b is equal to the natural log of a. So if we're trying to find what is a, A would be the inverse natural log of the natural log of A. So I'm going to say, how do I get the inverse natural log? I'm going to say EXP, which is that. And I'm going to highlight that. So EXP parentheses. So I got my A value. It's a very big number. That is fine. How do I get my activation energy? My activation energy is going to be this number times negative 8.314 divided by 1,000. This will put this in units of kilojoules per mole. Now, 8.314 is the gas constant, but in units of joules per mole Kelvin. And so, to turn that into kilojoules, that's why we divided by 1,000. So my particular numbers were 66 kilojoules as my activation energy, and my collisional efficiency was 2.63 times 10 to the 13th. That is how you would hypothetically graph this. We could then go into you could change things and say, the x, let's say the x, we'll change that to ln k. And that would be 1 over t. And we can even do things to modify the chart, like change the axes. Chart title. What is the chart title? What do we want to call it? Let's say ln k versus 1 over t. Then you can change the axes to, this axis reads, horizontal axis is 1 over t. 1 divided by t in the units of 1 divided by k. And what about the vertical axis? Vertical axis is just ln of k. That's all it is. And hey, I can print this off, and I have a nice little chart. And that is how you go about and do that. I know it's somewhat fast. If you still are struggling, come on in. I'd be glad to help you. Learning how to do this now is something that will ease a lot of work. See, I don't know how long. Let's see, how long have I been talking? I've been talking for like a half an hour. But that half an hour, I did all of the work. All of the works except for answering the questions. I did part A, I did part B, everything. All by myself. So, with that in mind, have at it.